I'm Joe Feeks, editor of Poultry Health Today, and with me is Dr. Keith Belk. He is department head of animal sciences at Colorado State University. Great to have you here, Keith.
Thank you. Enjoy being here.
The U.S. poultry industry has really been focused on salmonella over the last couple of years, ever since the new performance standards came out from USDA. They had sort of put Campylobacter on hold, but we do have new guidelines coming out this summer, as I understand it. So the industry is really nervous about meeting this performance standard for Campylobacter. Now, it's another bacterium, just like salmonella. It's another foodborne pathogen, but they're really two different bacteria, aren't they?
There's salmonella everywhere. I mean, there's salmonella in all foods, and salmonella is always a food safety threat. But Campylobacter is sort of a different beast. It's more anaerobic than those organisms, so it's more susceptible to being in oxygen. And it's also an organism that if you want to grow it so that you can study it, it's oftentimes very difficult to grow.
And I know what they've learned with salmonella is they pretty much said, look, processing can't do it all. We need to have better control efforts on the farm to reduce the amount of salmonella that's coming off the farm and into processing. Does the same hold true for Campylobacter?
You can never eliminate it from a production system, particularly a live production system. But your goal is to reduce it to levels that allow the plants to address it so that you don't end up with overwhelming the food safety systems that exist in the plant. But it's a very difficult thing to do, because whenever you change something in the live animal production system, you're literally changing the ecology of the organisms that travel with the product then. And so there's still an awful lot that we have to learn about how that ecology works.
And looking at Campylobacter on the farm, I mean, with salmonella, at least we have some very good vaccines that have been used in the broiler breeders and now are used extensively in the broilers too. But last I checked, there are no vaccines for Campylobacter. So what are things they can do on the farm to try to minimize that load?
Very little effort and resources have been brought to the table to address this organism. And so I think it's something that will require additional study with time, particularly if we want to control it.
So is it safe to say then, until we figure out how to control it on the farm, most of the focus will be on controlling Campylobacter in processing?
I think the onus becomes the plant's problem, and I think we need processing systems implemented in the plants that not only address the salmonella issue, particularly on parts, but also the Campylobacter issue.
And when you look at processing, is there a certain phase of processing where Campylobacter tends to rear its ugly head? Or put another way, is there a better time to try to control Campylobacter in processing?
In our studies thus far, and this may not be the true the facts as we move forward in time, but right now we've had the most success in poultry systems addressing it at the parts level, where the testing is going to be occurring for these performance standards. That's where, for whatever reasons, you tend to see higher prevalence. When you test whole birds after rinsing and chilling, you don't really find these pathogens. And probably we don't have a really good understanding of why that's the case. But you move the birds downstream and you turn them into parts, and then all of a sudden these pathogens show up. And therefore, at least so far, the best place to try and address them is at that point.
Let's talk about your research, because I know that you recently did a study targeting Campylobacter in the processing plants. How is it set up?
Well, we've done a number of studies to try and help production plants that produce poultry to address this issue. That has included everything from developing new kinds of equipment that allow you to treat the parts to kill the bacteria, to finding the right chemistry to use to kill the bacteria. And that's really hard to do, because companies have tended to think that if you use one series of intervention systems with one type of chemistry, that you end up killing all the pathogens that are there. And we've already talked about how pathogens differ significantly from each other. And so you have to believe that when you treat to kill one pathogen, you don't always get the other one. And I think that's what happens here with Salmonella and Campylobacter and maybe even other pathogens as well. And so the study we've just completed was, we actually, this was done in the laboratory. We tried to simulate a couple different application methods. And so we simulated immersing parts. In this case, we used wings versus the second treatment was, doing a study where we sprayed the compound on, much as you would in most real world plants. And we set it up to compare 5 different treatment levels. We had a negative control. We always, when we do microbiology studies like this, we include a treatment where you just spray water, because if you're going to try and test the impact of a chemistry in a system, you want to know that the chemistry is more effective than just spraying water. And so we always include a water treatment.
And that's the control?
Well, we have a negative control. So birds we don't do it, or parts we don't do anything on. Then we have a treatment where we spray water or immerse the products in water. And then we had 3 different chemical treatments. We had a sulfuric acid that's a buffered sulfuric acid that is it's a proprietary compound that has worked. It's very low pH. You can get the pH down as low as 1.0, and so it's highly acidic. And then we also tested a peroxyacetic acid compound, and then we tested a combination of those two. So we acidify a peroxyacetic acid, because peroxyacetic acid, even though it's called an acid, it actually kills bacteria with a different mechanism. And so in the combination chemistry, what we're trying to do is add together with one chemical compound, more than one mechanism for killing bacteria. In the case of peroxyacetic acid, it kills by oxidizing the bacteria. The really low pH buffered sulfuric acid compound kills it because it's highly acidic. And so you have then 2 mechanisms that you're using to kill the organism. And we wanted to see if, when you combine those technologies into the same compound, the same spray, if you will, if you sort of get an additive effect.
And did you?
And it turns out that you do. All 3 of those treatments were extremely effective against Campylobacter, which is in a laboratory more difficult to grow, as I've mentioned. The immersion treatment was much more effective than spraying the compounds on, as you might expect. All of them worked much better than just using water, so that was good news. The most effective treatment was the peroxyacetic acid, or the peroxyacetic acid combined with the acidification method using the sulfuric acid that's buffered. And then we added another layer to this study. We wanted to know what happens immediately after the application of the compounds, what the plant could expect right after they apply the compound to the parts. And then we also measured it again 24 hours later on the same parts to see if there was any additional impact that occurred as a consequence of the treatment. Sometimes you can injure bacteria but not kill them. And so over a period of time, they recover and they grow back. And so what we're interested in is death versus injury immediately after the treatment versus what that looks like 24 hours later after they've had a chance to recover and to begin to grow again. And in this study, it turned out that the combination treatment by far was the most effective after 24 hours of treatment. Significant reductions, both when the parts were immersed or when the compound was sprayed onto them. As much as 2 logarithm reductions, starting from an initial inoculum level of 3 to 4 logarithms of bacteria. So a really substantial reduction.
So let's talk about that a little bit. I mean, is it just a matter of having 2 products instead of 1, and that's why you're getting the better control? Or is there something in the relationship between the 2 products that helps them perform better?
it's using the two mechanisms that they bring to the table to kill bacteria. So when you blend them, they have a synergistic effect because one of them is killing the bacteria apparently by being really acidic, very, very low pH, while the other one is literally oxidizing the cellular membranes so that they can't metabolize. And so when you put those two things together, apparently with the Campylobacter, you sort of get this additive effect because you're basically doubling the number of mechanisms that you're using to kill the bacteria. And it shows up particularly after longer periods of storage, after 24 hours following application. So it's actually pretty exciting.
So based on your experience in the laboratory, what would you tell a processing manager about controlling Campylobacter in chicken parts? What would be your recommendations?
Well, I like this. I mean, this probably won't be at the end of all technological developments the only application that will work, but this application works. With the peroxyacetic acid in the industry, it's approved up, depending on where it's used, as high as 2,000 parts per million. We're applying it in this study at 500, 550 parts per million.
So considerably less.
Considerably less. And we're not acidifying using the buffered sulfuric acid to the level that we might use it if we were to just use the compound alone. We only went to a pH of 1.2. And so combining those two components was more economical for plants. I think this is a really good option for plants to consider, particularly as new equipment's being developed to go along with these compounds for application purposes.
Okay, so you'd recommend using them together, and then at what particular stage of processing would be the best time to, either with the dip or the spray, to use this combination?
What we're simulating here is as parts, so on the parts line or at the end of the parts line, where many plants are implementing these types of interventions. Ideally, if they could be immersed in the compound, that would be the very best effect that you could expect. But even spraying the compound had long-lasting effects clear out to 24 hours. And yes, I agree, the very best mixture was the peroxyacetic acid mixed with the sulfuric acid compound.
And one final question, based on your knowledge of Campylobacter, what else can they do in the processing plant besides these two antibacterials? What other things can they be doing to try to reduce the impact of Campylobacter?
I think a lot of the just good manufacturing practice requirements that most plants have in place, keep them clean while you're processing them, keep feathers off of them, keep workers that are handling them clean, keep equipment sanitary and clean, get them chilled quickly. We're still advocating the use of an antimicrobial in the chilling. It's still a good practice. And then as they, in the deboning rooms, as they turn the carcasses into parts, systems to help prevent the accumulation of bacteria and contaminants are really, really important. So, operational sanitation in plants is still very key to preventing, widespread high prevalence of any organism.